Well, we're getting a lot of practice on finding the zeros of polynomial functions. So let's see, here we are. We're supposed to state the number of possible real zeros and turning points for each function, then determine all the real zeros, and we may in fact have what are called repeated zeros, which I don't think we see in this example, but we will in the next. Now let's look at what we've got. G of x equals negative 2x cubed minus 4x squared plus 16x. And as always, first thing when I'm wanting to factor, I need to think about, can I factor out the greatest common factor? Well, I got a negative 2, a negative 4, and a positive 16, along with an x cubed, x squared, and an x. Well, what if we factored out negative 2x? All right, well, let's see. If I factor out negative 2x from negative 2x cubed, I'm going to end up with x squared. And if I factor out negative 2x from negative 4x squared, I'm going to have positive 2x. And if we factor out negative 2x from positive 16x, we're going to have negative 8. And if you wanted to distribute that negative 2x back to the x squared plus 2x minus 8, I believe you'll find you'll end up with 2x cubed minus 4x squared plus 16x. Well, we've got one factor here. We're going to factor the polynomial. I'm going to need me a couple of parentheses. I got it down to just an x squared, so I'm going to put an x in the left-hand side. My last term, my term with my constant is negative. It means I got to have a positive and a negative inside the parentheses. The only way the two numbers are going to multiply together and get a negative. One's got to be positive, one's got to be negative. And I need two numbers that are going to multiply to negative 8 and add to positive 2. Now we'll just go through the progression. 1 and 8, 9. How about 2 and 4? How about if we had positive 4 and negative 2? Well, 4 times negative 2 is negative 8. And 4 minus 2 is positive 2. Looks pretty good. Now let's set all the factors equal to 0. Did we talk about how many possible real zeros? I don't think we did. Well, we got x cubed, so we're going to have 3 possible real zeros. Turning points will be 2, which is the 3 minus 1. Let's see, negative 2x equals 0. We divide 0 by negative 2. Well, 0 divided by negative 2 just remains 0. So there's one of our real zeros. And then we're going to take x plus 4, set it equal to 0. We're going to subtract 4 from both sides to isolate the x. And x is equal to negative 4. There's the second of our 3 possible real zeros. And then lastly, we got x minus 2 equals 0. We're going to add 2 to both sides. And shazam, x is equal to 2. So our 3 real zeros with this function that has 3 possible real zeros and 2 turning points are negative 4, 0, and 2. Now in this case we didn't have any repeated zeros, as I didn't think we would, but I believe we will in the next one, so let's get on with it. Alright, so I got f of x equals 3x to the 5th minus 18x to the 4th plus 27x cubed. How many possible real zeros can I have? Well, you probably know, 5. And what about the turning points? Well, 5 minus 1 is 4, so it's 4 turning points. But let's factor. And again, what is the greatest common factor that I can factor out of this? Well, I got a 3, 18, 27. Those are all multiples of 3. And then I got an x to the 5th, x to the 4th, x cubed. Well, shazam. We could factor out a 3x cubed. Once we do, we would have x squared let's see, 3x cubed into divided, take negative 18x to the fourth divided by 3x cubed. Well, that's going to be negative 6x. And 27x cubed divided by 3x cubed is going to be positive 9. All right, so I got one factor over here. Let's go for these other two. I'm going to draw two parentheses. I got a single x squared. So I'm going to put x and x. And now I need two numbers that are going to multiply to positive 9 and add to negative 6. And since this is positive and that's negative, I know inside my parentheses are going to be negatives. Well, what about 3 and 3? Well, negative 3 times negative 3 equals positive 9, and negative 3, or negative 3 minus 3 is negative 6. So we've got our factors. Now let's solve for our zeros. We set this 3x cubed equal to 0. We divide 0 by 3, which of course is going to be 0. So x cubed is equal to 0. And then we cube both sides so that, well, let's do it like this. Cube root of x cubed and the cube root of 0. Well, the cube root of x cubed is x, is what we're looking for. And the cube root of 0 is, in fact, 0. Now, what about our x minus 3? Well, that x minus 3 equals 0. Add 3 to both sides, and we got x equals 3. But I got that twice. I got x minus 3 times x minus 3. So we have a repeated 0 at when x is equal to 3. So we got a 0 at 0, and we got a 0 at 3, and we say that that's with multiplicity of 2. In other words, it happens twice. And we might even be able to say that we got multiplicity of 3 with that 0. But there we are. What do you think? I'd have to graph that. If it bounces off the x-axis at 0, then we've got multiplicity of 0 at 3. And we should be bouncing off the x-axis at positive 3, which indicates the multiplicity of 2. You might want to get on the calculator and take a look at that. Do a little exploring on your own.